Today, in this video, we are going to talk about ether synthesis. Before we go over the mechanism, it is important to understand what an ether is. An ether is an organic compound that consists of two alkyl groups, which are chains of carbon and hydrogen atoms, bound to an oxygen atom. Here are some examples of ethers. We have a diethyl ether, methylpropyl ether, THF, ethylpropyl ether, and benzyl ethyl ether. Now that we know what an ether is, we can learn how to synthesize one. The way I will show you how to synthesize an ether is through Williamson ether synthesis. We start with an alcohol, and since this is an acid-base reaction, we deprotonate it with a base. A common base used in Williamson ether synthesis is sodium hydride, or NaH, because it is a strong base. Here we have our alcohol, propanol. Due to the electronegativity of the oxygen atom here, the hydrogen atom has a partial positive charge. We always start our arrows in the mechanism from an electron-rich region to an electron-poor region. So our arrow in this example goes from the electron-rich hydride ion to our partially positive hydrogen atom. This grabs the hydrogen, and this bond here, which denotes the shared electron, goes away because the oxygen here is no longer sharing with the hydrogen atom. We have just deprotonated the alcohol. These two hydrogen atoms now form hydrogen gas, which bubbles out of the solution. The Na here becomes Na+, which is a spectator ion, so it is no longer used in the solution. Our next step in the mechanism is alkylation. Halogens such as fluorine, chlorine, bromine, and iodine make excellent leaving groups for our SN2 reaction, so the mechanism is performed with alkyl halides, which is a chain of carbon and hydrogen atoms and a halogen. Again, we always start our arrow from an electron-rich region and end it in an electron-poor region. We want our arrow to go to the carbon next to our leaving group because of the electronegativity of our leaving group. Just like in the H, our carbon here is going to be partially positive because of the electronegativity of bromine. Just as before, the bonds between the carbon and the bromine will break, and bromine is kicked off and replaced with the alkyl part of our alkyl halide, so these here, to form our ether, dipropyl ether. Next, I want to show you a trick for some of the more straightforward examples of ether synthesis. We will be using the same example as before because we already know the synthesized ether. The hydrogen here is replaced with the alkane here to form our ether. Because we know that NaH is a base and it's going to take away this hydrogen to form hydrogen gas, and Na is going to be a spectator ion, we already know that we can take this because the bromine will be kicked off, so the alkyl part of the alkyl halide will form with this part of the, this is an alkoxide. The alkoxide and the alkyl part of the alkyl halide will form our ether. Now that you know the process, go ahead and try this example for yourself. Go ahead and pause the video now. So hopefully you've tried it at this point, and you should have an ether that looks like this, butyl ethyl ether. Here is the mechanism for this process. Just like in the previous examples, our arrow goes from an electron-rich region to an electron-poor region and deprotonates this alcohol. Then, the alkylation step, our arrow going from the electron-rich to electron-poor regions, kicks off the chlorine and replaces it with the alkyl part of the alkyl halide, synthesizing our butyl ethyl ether. Thank you for watching my video. I hope this helped and you understand ether synthesis a little better.